Throughout the last 200 years of naval history, one constant has generally remained true. That's the inexorable increase over time in the size of naval ships. Larger hulls traditionally meant greater firepower, longer endurance, and better survivability. Destroyers, for example, went from small vessels designed to ward off torpedo boats to the large floating sensor and missile complex that we see today. However, the rise in size was by no means universal. The Jeune École was a revolutionary naval theory emerging in France in the late 19th century, advocating for a departure from traditional battleship fleets in favor of small and agile vessels bristling with anti-ship weapons. Its central premise was that speed, concentrated firepower, and the proximity to friendly bases could offset the size advantage of bigger ships, especially in coastal waters. Today, this model of Jeune École has made a strong comeback in the Visby-class corvettes of Sweden. In the coastal waters of the Baltic, the Visby goes all in on the idea that a small platform that can detect, evade, and threaten larger enemies such as destroyers and cruisers, leveraging low observability, missile firepower, and geographic familiarity to punch above its weight and shift the local balance of power. The origins of the Visby class trace back to Sweden's long-standing focus on littoral defense. Sweden's strategic environment is shaped by the Baltic Sea, a semi-enclosed, shallow, and crowded maritime theater characterized by archipelagos, constrained maneuver space, and short engagement distances. In such waters, certain traditional assumptions about naval power are altered. Large surface combatants become more detectable, more targetable, and more constrained, and unable to take advantage of their superior operational range. Smaller vessels, if properly equipped, can exploit the crowded nature of the waters and the short reaction times by prioritizing stealth and offense. With a displacement of roughly 640 tons and a length of just over 72 meters, the Visby is small even by Corvette standards. Its angular, tumble-home hull, faceted surfaces, and the absence of protruding features give it an almost futuristic appearance. This visual distinctiveness is not aesthetic experimentation, but reflects a design philosophy centered on low observability. For the Visby, the ability to achieve the elements of surprise basically defined every major design decision. The Visby's development built upon earlier Swedish stealth experimentation, most notably the test ship, the Smidge, launched in 1990. The Smidge validated key stealth principles, including radar-deflecting geometry, use of composite material in construction, and signature management techniques. These lessons fed directly into the Visby program, initiated in the 1990s and executed by Kockums in Karlskrona. The result was a technological jump rather than incremental improvement. Instead of adapting stealth to a tried-and-tested conventional hull, the Visby was designed from the keel up as a low-signature combatant. Central to this transformation is the ship's composite construction materials. The hull employs a sandwich design consisting of a polyvinyl chloride core layered with carbon fiber and vinyl laminate. This structure offers several advantages. From a weight perspective, composites provide comparable strength at roughly half the mass of equivalent steel constructions. Reduced weight directly translates into higher speed, improved maneuverability, and lower propulsion demands. More critically, composites fundamentally alter the vessel's signature characteristics. Unlike steel, the composite's hull is non-magnetic, significantly reducing susceptibility to magnetic mines and magnetic anomaly detection systems, which are commonly found on surveillance aircraft. This reduced magnetic signature is a core survivability feature in the mine-heavy littoral environment. The composite construction also contributes to radar and infrared signature reduction. Composite surfaces can be manufactured with high conductivity and exceptional smoothness, minimizing irregular reflections and supporting radar-deflecting geometry. Thermal insulation properties reduce heat transfer from internal machinery to the outer hull, lowering the infrared signature for the vessel. The reduced visibility across both the radar and infrared domains not only reduces the risk of detection by the enemy, but can also make it harder for enemy missile guidance to target the Visby. In the event of fire, composites also behave differently than metals, offering improved survivability under many conditions. Composites materials therefore improves structural efficiency, survivability, and stealth performance. The tumble-home hull form, combined with sharply faceted surfaces, deflects radar energy away from the emitter rather than back towards it. Protrusions are minimized, and many systems and weapons are enclosed within the hull. The 57mm Bofors gun, for instance, is housed within a stealth cupola, with a retractable barrel to preserve the vessel's low radar profile when not in use. Anti-ship missile launchers and torpedo tubes are similarly concealed. Exhaust gases are redirected through outlets near the waterline, reducing thermal signature. Even deck fittings, rails, and mast are shaped and positioned with signature management in mind. The Visby has an integrated radar mast that blends into the stealth superstructure, as opposed to a traditional open mast with exposed antennas. Inside the mast are the ship's combat radars, navigation radars, identification, friend or foe, communication antennas, and the tactical air navigation system for the helicopter. The integrated mast helps to keep the sensors and communication systems hidden behind radar transparent panels, in turn mitigating their contribution to the ship's radar signature. The cumulative effect of all these stealth features is dramatic. Designers have described the radar cross-section reduction as approaching 99% relative to conventional vessels of a similar size. Such figures do not imply invisibility, but rather a substantial compression of detection range. Findings by commercial navigation radar shows the Visby appearing more akin to a small buoy than a warship at a distance of around 1.5 nautical miles. While commercial radar observations are not equivalent to military-grade sensor performance, they nonetheless underscore the scale of signature reduction achieved. During combat, a smaller radar cross-section reduces the time available for enemy detection, classification, targeting, and engagement. In the anti-surface warfare role, the Visby carries 8 RBS-15 anti-ship missiles for the engagement of enemy warships, with a secondary land attack capability. The RBS-15's sea skimming flight profile, terminal maneuvers, and a combo of different guidance systems make it a credible threat to vessels far larger than the launching platform. Combined with the Visby's low observability, the long-range anti-ship missile, at least in the context of the Baltic, provides the Visby the maximum chance of first detection and first salvo advantage. Sweden is in the process of upgrading the RBS-15 anti-ship missiles on the Visby from the current Mark II to Mark III, with a commensurate increase in range from around 100 kilometers to over 200 kilometers. While 100 kilometers may appear low in terms of range, they are more than enough in the constrained waters of the Baltic Sea, assuming the Visby can approach the target undetected. Sensors and combat systems support this mission. The Saab 9LV Combat Management System integrates radar, fire control, and weapon coordination into a cohesive decision framework. The Sea Giraffe AMB 3D surveillance radar provides air and surface search capability, while the Seros 200 fire control radar supports the targeting of the RBS-15 sea skimming missile. Additional radar surveillance systems complement the sensor suite. The design emphasis is clear. Maximize situational awareness while minimizing on-platform exposure. The midlife upgrade for the Visby class will add a meaningful air defense capability. In November 2023, the Swedish Navy ordered each Corvette to be fitted with a vertical launch system composed of 9 cells. Each cell is expected to carry the Sea Scepter air defense missiles. 4 Sea Scepters can be quad-packed in each missile cell, giving a total of 36 short-range air defense missiles across the 9 cells. The Visby's anti-submarine warfare capability is real and tailored to the operational environment. The Baltic Sea's acoustic complexity, shaped by shallow depth, variable salinity, and dense traffic, presents both challenges and opportunities for submarine detection. The Visby employs a layered sonar architecture, including a hull-mounted sonar, a towed array sonar, and a variable depth sonar. This combination enables detection across different depth, different salinity, and acoustic conditions. Hull-mounted sonar systems provide immediate proximity awareness, while towed arrays enhance passive detection performance by distancing sensors from ship-generated noise. Variable depth sonars allow operators to position active sonars at optimal depths, depending on the acoustic environment in which the target submarine is believed to be hiding. Torpedo armament is available. Lightweight torpedoes, such as the Torpedo 45 or Torpedo 47, provide a responsive anti-submarine weapon. In a defensive littoral context, the Visby functions as both hunter and deterrent, complicating adversary submarine operations and reducing freedom of maneuver. Aviation facilities provide substantial utility to the Corvette, including for anti-submarine warfare. The Visby's flight deck supports the AW-109 helicopter, a platform capable of surveillance, targeting support, and limited anti-submarine functions. Although lacking a hangar, the helicopter capability provides valuable reach beyond the ship's organic sensor horizon. In littoral warfare, where detection geometry and line-of-sight constraints are critical, airborne assets significantly enhance situational awareness. Sweden's coastline is defined by archipelagos, narrow passages, and complex littoral zones. These waters favor small, agile platforms capable of rapid maneuver and high speed. The Visby's water-jet propulsion system supports a high speed exceeding 35 knots, and the ship's shallow draft supports operations in shallow waters where larger vessels face constraints. Sweden's principal maritime opponent in this theater is Russia, specifically the assets of the Russian Baltic Fleet. Russia deploys a mixture of small missile ships, corvettes, submarines, and larger surface combatants across its naval forces. The Visby is not designed to mirror the substantially greater Russian naval capabilities symmetrically, and instead engaging in asymmetric deterrence. Against smaller missile ships such as the Buyang M or Karakurt classes, the Visby's stealth characteristics and sensor integration offers a detection advantage. In engagements where both sides rely on radar and electronic sensing, reduced radar signature directly affects reaction times. The ability to detect first and launch precision anti-ship missiles can decisively shape outcomes. More striking is the Visby's relevance against larger vessels. Consider a frigate, such as the Admiral Gregorevich class, with far greater displacement, sensor capacity, and defensive systems. This class of frigates represents a formidable opponent. Yet, the engagement's dynamics is not purely determined by capabilities alone. Detection probability and the elements of surprise remain decisive. The stealthy Visby, operating within a cluttered littoral environment, armed with sea-skimming missiles, can impose serious risk on larger vessels that are inherently more visible. The Russian Navy's Project 636.3 improved Kilo-class submarine, renowned for being extremely quiet, is a potent adversary. The Visby's sonar suite, optimized for shallow and complex acoustic environments, is specifically tailored to challenge such platforms. Russia's larger nuclear-powered submarines, like the Akula class, are generally ill-suited for operating in the Baltic, as the generally shallow waters of the Baltic do not allow the larger Akula to hide effectively. The Visby's layered sonar system should do very well against large nuclear submarines in these constrained waters. While no surface ship can guarantee dominance against submarine, the Corvette's comprehensive sonar suite combined with lightweight torpedoes presents a credible deterrent. Even against major combatants not typically deployed in the Baltic, such as the Udaloy-class destroyer, the Visby's operational strength remains relevant. The Russian Navy's large surface combatants are inherently non-stealthy, meaning the Visby can see the Russians before they can see it. This gives the Visby a crucial advantage in the form of the first salvo. In contrast, Russian destroyers may struggle to find the Visby and to target the Corvettes with their own missiles, owing to the stealth capability of the Swedish warship. The Visby exemplifies a broader strategic principle that smaller, lower signature platforms can impose disproportionate risk on larger, more expensive assets. This is not an argument that corvettes should replace destroyers or frigates, but that in specific theaters, particularly littoral environments like the Baltic Sea, stealth and speed can rival scale. As we discussed earlier, recognizing evolving threats and technological advances, Sweden initiated midlife upgrades for the Visby class. These enhancements include new anti-ship missiles, updated torpedoes, and the integration of surface-to-air missiles. Such upgrades are designed to preserve operational relevance well beyond 2040, ensuring that the platform's stealth-centered philosophy continues to deliver combat value. Ultimately, the Visby-class corvette represents a distinct answer to a fundamental naval question. Instead of asking how to build larger and more heavily defended ships, Sweden asked how to build vessels that are harder to detect, harder to target, and still lethal for their specific environment.